Hi friends, now we will discuss the molecular orbital diagram for the heteronuclear molecules. So up till now you have seen that we had been discussing the homonuclear molecules. Now there's the turn for heteronuclear. So heteronuclear means now we will have the two atoms involved in the molecule. These two atoms will be different, right? So that is why it is heteronuclear. Hetero means two different atoms forming a molecule, right? Okay, so homonuclear, we had similar atoms forming the molecule, so that was homonuclear, and heteronuclear will have different atoms. Okay, now for heteronuclear molecules, the basic things that we had learned about the molecular orbital electronic configurations, they will remain the same. Only few differences will be there. So first of all, let's discuss what are the differences when we are encountering the heteronuclear molecules. I have written a few important points. Let's go through them one by one. Okay. So first of all, the principles involving the distribution of electrons in the molecular orbital, they remain the same, right? So the way we distribute the electrons energetically from low energy to high energy, and that distribution of electrons, they remain the same in the heteronuclear molecules also. So no change in that. Okay. Then what is the change? Now for heteronuclear molecules, the molecular orbitals are not symmetrical, right? As we had seen for homonuclear diatomic molecules. Not symmetrical means now you won't get diagrams like this where the two atomic orbitals will equally, they will give rise to two molecular orbitals at an equal distance, and again the higher orbitals will give rise to different molecular orbitals at equal distance. So that is the meaning of unsymmetrical. Now this distance will be different. Why? Because the energies will be different. Now also because two different atoms are involved, so they will have their atomic orbitals at different energy levels. Okay, now the formation, also the third point says the formation of non-bonding molecular orbitals. Okay, now from here onwards we will see, we will encounter several non-bonding molecular orbitals also when we discuss the molecular orbital diagram for heteronuclear molecules. So till now we had seen bonding and anti-bonding, right? So bonding and anti-bonding we had seen. Now we will encounter the non-bonding orbitals also. So what are non-bonding orbitals? Non-bonding orbitals are such orbitals where the addition or the removal of electrons, that does not impact the molecule energetically. That molecule remains indifferent to that addition or removal of that electron in that particular orbital. So that is why it is known as non-bonding. No contribution towards bonding, right? Electrons are there in that orbital, but that doesn't contribute towards the bonding. That is why they are known as non-bonding. So how these non-bonding orbitals are formed and what is their contribution and how they are located, so that we will discuss when we will discuss the formation of these non-bonding orbitals in the molecular orbital diagram. So these are the important points. First of all, the diagram will not be symmetrical as we had seen for homonuclear diatomic molecules, and secondly there will be the presence of non-bonding molecular orbitals. So these 2 points are very important. And then what is the reason for these two differences? The reason will be, we have two atoms, right? Obviously there will be the electronegativity difference between the two atoms. One atom will be more electronegative, other will be less electronegative. So this is very important. All these differences are because of the electronegativity difference between the two atoms, right? Different atoms, different electronegativities. Okay. And also the second point here in the reasons, it says that atomic orbitals of the more electronegative element are lower in energy. than atomic orbitals of the less electronegative element. That means if A and B are two atoms, and let us say this is more electronegative, right? And if B is less electronegative, okay, then the atomic orbitals of A, the more electronegative element, will be located at a lower energy than the atomic orbitals of the element B, which is less electronegative. So low energy, why low energy? Because obviously when the electron charge density will be more at an atom where the electron charge density is more, then that will be more lower in energy, or in other words that will be towards more stable, towards low energy and towards more stability. So where there is electron charge density, that will result into bonding, and that will give the molecule its stability. That is why this more electronegative element will be more towards the lower end. So because that gives the molecule its stability, right? Because the electron charge density will be located towards that molecule which is more electronegative. Electronegativity, we all know that it is the tendency to attract electrons towards itself, right? So attract electron towards itself means that the electron charge density will be more towards the more electronegative element. Okay, so based on these points, and also one more point I want to add here, that the bonding molecular orbitals, right, what we get when the atomic orbitals they combine linearly, LCAO method. So whatever bonding molecular orbitals will be, when we whatever we will get, that bonding molecular orbitals, these the atomic orbitals that contribute towards the bonding molecular orbital will be the atomic orbitals of more electronegative element. Okay, so in that is the same whatever we had discussed it is a different method of saying that same thing, right? We said that more electron charge density, whatever electron charge density, whenever it is more towards that particular atom, that will be located lower in energy, and obviously the bonding molecular orbitals will be contributed by that element which has more electron charge density. That means the more electronegative element. So these all these are the different newer things than the homonuclear diatomic molecules. So that is why these points are very, very important when we draw the molecular orbital picture of the heteronuclear molecules. And then in these heteronuclear molecules, the first molecule that we will discuss is the carbon monoxide molecule, or the CO molecule, right? So now we will discuss the CO molecule. Okay.